Assalamualaikum and hi everyone. I am Nur Hidayah Binti Syarif from Group 14. We'll present about our mini project about design and electromagnetic analysis of 12-slot 8-pole permanent magnet brushless machine. What is permanent magnet brushless DC motor? Brushless DC motor is one of the motor type that commonly used in our industry nowadays. The main component in this motor is rotor in permanent magnet and stator in armature winding. The application of this motor, first for the consumer electronic, second heating and ventilation, and this motor commonly used in industrial engineering. Why this motor is commonly used? Because of its advantage. First, this motor has higher efficiency. Second, it has better speed versus stock characteristic. Third, this motor is noiseless operation. And lastly, this motor has high speed range compared to brush DC motor. Next is methodology. In order to design this motor, there are several steps that need to be taken. First, we start this mini project by calculating the motor dimension. Then, start to design the stator outline using AutoCAD based on the dimension that had been calculated before. After that, the 12-slot 8-pole stator outline draft design will be imported into the ANSYS software. We design the motor in ANSYS to analyze the result for the vector potential and flux density, big air gap, clogging torque, and back EMF. Lastly, conclusion can be made based on the result that been observed. Based on the methodology, we start this mini project with calculating the motor dimension. We can use the dimension that has been given in the project as shown in the table in the slide to start our calculation. First, we need to determine the number of slots per pole. Based on the calculation, we identify this motor is non-overlapping motor because the number of slots per pole is less than 1.5. Other important parameter to draw this motor in AutoCAD is first, tooth body width WTB, stator yoke thickness known as WSY, rotor yoke thickness WRY, tooth and height WTE, outer radius of slot opening RT, magnet outer radius RM, and inner radius of rotor yoke RR. The AutoCAD with full dimension is shown in the figure above. For the layout winding, we need to execute another calculation to obtain the motor slot pitch, pole pitch, number of coil span and number of slot per phase, and number of coil per phase. The formula used to calculate the slot pitch is 360 degree divided by the number of slot, so we get the value is 30 degree in mechanical unit. If we change to electrical, the value is equal to 120 degree. Next, to calculate the pole pitch, we use the formula 360 degree divided by the number of pole, which is equal to 8. So the value that been obtained is 45 degree mechanical and equal to 180 degree electrical. Number of coil span that we get is 1.5. Which means that the motor is non-overlapping type. Then, number of slot per phase, we multiply with 2 and divide with 3 phase. The value that we get is 8 slot per phase, and number of coil per phase is equal to 2. The layout winding of this motor and the AutoCAD model for ANSYS is shown above. Okay, next I will continue with the FEA model. The first step to design this non-overlapping permanent magnet brushless machine is by importing drawing from the AutoCAD file. Then, make sure the SI unit length setting in the ANSYS are in millimeter. After that, we start to design for the stator part by using Boolean subtract, and then do the design for the rotor part by placing the magnet in a right place according to the pole, which is north and south pole. All the coil part for the basic model are assigned in copper material. Create the inner and outer region under vacuum part by inserting the value of diameter gap, diameter yoke, and the core info. The figure for the FEA model is shown above for 12 slot and 8 pole model. During the design process, we will analyze the changes happen in the motor in terms of vector potential and flux density. The first figure shows the flux line vector potential in the motor. The magnetic vector potential is one of the quantity vector used in electromagnetism, which can be used in determining the electrical field. Magnetic flux will flow from the north pole, linking adjacent south poles and return back to the opposite end. When the voltage been applied to the motor, current will start flowing and the magnetic field also been produced. Next, in terms of flux density, the figure is shown above. Figure shows the distribution of magnetic field across the motor during the simulation. The highest value of magnetic flux that flow in this motor is 1.332 Tesla at the stator tooth, which in yellowish green color. Based on the observation, flux density happen under the knee point of the curve, which is 1.8142 Tesla. Next, we will discuss about the mid-air gap. In motor designing process, the air gap is one of the important factors that need to be included. An air gap helps to improve the reluctance of the motor and all at once increasing the current flow through the coil. Other than that, magnetic flux flow in the motor will be expanded according to the size of air gap that been designed in this motor. As can be seen from the graph of mid-air gap flux density versus radial flux density and tangential flux density, the magnetic poles of the motor produce sinusoidal waveform. However, at the slot openings, there is some distortion of the waveform induced by the slotting arising from the stator. The value of radial flux density obtained from this motor design is 0.8 Tesla in positive region and negative 0.8 Tesla in negative region. As for the tangential flux density, the maximum value for both region is 0.36 Tesla and negative 0.36 Tesla.
Assalamualaikum dan selamat sejahtera. I'm Shafiq. Will continue this presentation. Back EMF. Back electromotive force refer to the voltage that occur in electric motor when there are relative motion happen between magnetic field from magnet and winding of the motor with the armature. Based on the calculation for the 8-pole motor, 750 RPM need to be inserted in the analysis in order to obtain the 1 cycle value of the back EMF. Figure show the value of back EMF from the simulation for induced voltage in phase A, phase B and phase C. This is the waveform of the back EMF. The EMF generated by a running motor because it consists of coil turning in a magnetic field. It opposes the voltage powering the motor. This is graph of the Coggin torque. Coggin torque is the torque used to overcome the opposing torque produced by the exciting magnetic force between the rotor magnets and the teeth of the stator. From the simulation shown in the figure, the maximum value of the Coggin torque for this motor is 200 Nm. The value of the cogito can be reduced by skewing the rotor magnets or by adjusting the number of poles and slot of the motor. Cogito occur in permanent magnet motor, including brush and brushless DC motor and synchronous AC motor. Because it occurs in an unenergized motor, it is sometimes referred to as open circuit tow. Conclusion. In conclusion, the objective of this paper is to design the motor with 12 number of slots and 8 number of poles by using AutoCAD and Anisis software have been achieved. The stator body is orange to the magnetic pole, allowing the magnetic flux to flow into the air gap and flow into stator body at the end of the stator tooth tip. So that the performance of the motor can be evaluated in terms of flux density, rotor mechanical angle, back electromotive force, and cogito. That's all from us. Thank you.